So welcome to the first autumn weather briefing. So this first week is already bringing some heavy rainfall and severe convections to parts of the Mediterranean and southern Europe. But other areas will also get wetter and windier weather as low pressure systems will approach Western Europe and even a tropical cyclone. So let's start with the current situation and see what is happening at highest levels. This image shows the geopotential and isotex at 300 overlaid with the water vapor 6.3 from FCI. And over the Atlantic, north of jet stream, so the area of these yellow lines, there is a large mid-latitude trough, and to the south, there is a subtropical ridge. In between, there's some kind of, in this area here, in between some cyclogenesis, a frontal system that's already there, and is just northwest of Azores, and is going to have an important role in the next days. In the bottom left corner, we can already see Hurricane Gabrielle, and I will show you later what is the trajectory based on the latest forecasts. So moving eastwards, we have here a trough that is approaching Western Europe, and the frontal system associated, which crossed Azores yesterday, is now slowly stretching as it moves towards the ridge over North Sea. This ridge, together with the cutoff flow over France, will become an higher over low pattern for the next days. We'll stay like this for the next days, and it brings somehow some stable weather in the north, the dry weather, and some persistent rain and severe weather to the south and the central part of Europe. So it's more or less a block pattern, and it's going to stay here for several days. And just further east, there is the ridge, some kind of blocking ridge is persisting in this area in Southeast Europe. It's also blocking the movement of the system over over France, and there is a deep trough over East Scandinavia, and there are also some small waves or troughs that can also be found over Turkey and further east. And you can see there's not a lot of darker areas in this area, so this whole zone over the Atlantic very humid, with upper level very humid in the upper levels, and but also over Europe. So with the Airmass RGB, we can see some different cloud features over the Atlantic. It's very busy, and there are not as much cloud features over continental Europe, except, of course, the system over the central Western Mediterranean. So this system, it's very big and affecting a lot of parts of Europe. Let's see more or less this area. So this main system is showing some thick cloudiness and deep convection surrounded with a frontal band over Central Europe. It is more or less going to stay stationary, and so bringing persistent rain over these areas. And we also can see some brownish colors behind, which means that some dry stratospheric air is present, so some convection and PV anomalies in the area. So this is an area that can have also some more convection underway. The green colors that are consistent with the synoptic circulation, so that's this kind of supports, so this synodic circulation supports a plume of warm and humid air mass over central Mediterranean. So this is the kind of color that is related to warm and humid air mass. And we also have this colder air mass. It's like more purple, and from the north that is moving deep into West Central Europe. And you know, this boundary will be causing some high impact weather in the region. So this whole area here is the boundary with cold air from the north and drier, and the warm and more humid from the south. So as I said, the busy Atlantic, so several clouds, frontal cloud bands, some stretching over here, some stretching. It moves, these systems are moving towards the ridge over British Isles, and it's making this ridge is making very difficult its movement. So they are stretching over here, but somehow some cloud, some rain bands are moving north and will affect the British Isles. And over Iceland, as some convective cloudiness around it. Also, we see some cloudiness, just kind of convective form. And we also see with the mean sea level pressure some strong wind gradient that will cause some high waves in this area too. Near Azores, at the moment, we have the high pressure system that's more or less dominating. But on Friday, I will show you later, on Friday we'll be affected by both the Hurricane Gabrielle and the frontal system I mentioned before in the previous slide that's now in northeast of the hurricane. So these systems, they both are going to interact, and their interaction will be more or less near or over the Azores. This interaction has to be closely monitoring because can bring more severe weather than expected. And farther east, we can see the frontal, this is a frontal cloud band that is going to stay more or less stationary in this area. So at surface levels, so in your left side, you can see the busy Atlantic with lots of this reddish cloudiness, and this is thick cloudiness, and the lowest clouds are very hard to see, and beneath this cloudiness, and some darker black, dark blue colors, that's thin cirrus, but mainly these systems around the Atlantic, they are bringing lots of this area here, lots of rain, and some rain also here. They're moving towards west, and of course the hurricane Gabrielle on this part of the Atlantic. On the right side of the image, we have some areas of clear sky. So you see the frontal cloud band that I mentioned before. It's here. It's going to be more or less stationary in this area. And we have the clear skies north and south, and in some areas here we can see that it must have been a cold night for some, and in small areas it can be some fog patches and low-level clouds and these whitish, very whitish colors, but the main systems, of course, are this frontal band and some areas of precipitation associated with the trough that we saw earlier, and of course over Italy, Mediterranean, France, Germany, all the surrounding countries, Croatia, Adriatic Sea, and we also have here some lightning accumulated flash area. If you see some small dots, yellow, red, dots, so indicating that at 6 UTC there was already, and from several past hours, there was already some convection and severe convection. And some details about the system. So this is from ePort, so the 10.8 infrared and the 6-hour accumulated lightning. So the yellow is the most recent. This was at 6 UTC. So it was a night, during night, lots of convection in this area and severe convection, as I said. Very unstable, so for sure. And we can see also from these products from the nowcasting SAF. So you can see the lifted index. It's a clear sky product. So you can see some areas of bluish gray tones that are in the clear sky zones, indicating that, of course, it is unstable. So it's a good product to help monitoring unstable areas, and it's also have the convective rainfall rate. And in this area here, it's 6 UTC. You can see that there are some spots here, about 50 millimeters per hour. So very high values of convective rainfall rate. Crossing this system, crossing long-lived system that crossed Sicily. And also, just to show you this one, I think it's important because sometimes ESCA twins can help monitoring convection over water, in this case, near Italy. And this is from yesterday, near 9 UTC. So this pass of ASCAT C shows very well the coastal convergence helping the development of that supercell that you can see here with the 0.6 visible with 500 meter resolution, and you see the convergence in this area, so helping and maintaining this system. So before I finish my presentation, some information about Hurricane Gabrielle. So yesterday, Gabrielle was a Category 4 and a Category 4 hurricane. And so, which means is a major hurricane with sustained winds between more or less 110, 130 knots. In this image, we can see very well, it shows the high of the hurricane. And you can see the upper level clouds spreading around it. And in this RGB, cloud phase RGB, remember the blue shades are ice particles, ice clouds, and larger particles are the darker tones, so dark blue, and the small ice particles are the light blue tones. Near Azores, you can see some areas of frontal system that crossed Azores yesterday, so it was crossing Azores. And you can see some water clouds. The water clouds are representing in the pinkish colors, and some yellowish colors are water clouds. So the darker tones in the pinkish represent large droplets, and the yellowish tones mean small droplets. So again, ASCAT saw the center of Gabrielle some hours ago, and we can see some force 8 in Beaufort scale and 9 near the center. And here we have some ambiguities that it's usually it can happen, but at least force 8 it is around the center at early today. and it's moving, Gabrielle is moving, as I said, towards Azores. So this is the last official forecast from National Hurricane Center. So Gabrielle, at this time, at 9 UTC today, it was a Category 3 hurricane with sustained winds of 100 knots and estimated mean pressure of 1959 hectopascal. So this is information from their products. Is moving relatively fast towards the east-northeast, around speed around 22 knots. Gabrielle is expected to move between the, as I showed you before, if you remember, the subtropical ridge over the central Atlantic and the large mid-latitude trough over the North Atlantic. And Gabrielle is going to be in an area with some increasing vertical wind shear, some cooling ocean water. So these are some ingredients that should cause the system to weaken. Nevertheless, the baroclinic interactions with that nearby trough could maintain its intensity. So for Azores, main hazards will be the storm surge that can cause coastal flooding, big waves, strong wind gusts, and heavy rain affecting all islands. Some outer bands of Gabrielle could affect also the areas more eastward. Well, it depends where it's going to cross the islands. And from ECMWF at 0 UTC today, so Gabrielle will affect also continental Portugal mainland as a tropical storm, a little bit higher intensity than the last National Hurricane Center forecast, so a little disagreement here. Portugal is still expected rain and wind and large swell at the coast, and also waves can affect Madeira also. For the current situation, that's all for my side. Thank you so much. Keep safe. Some red warnings for Germany and Croatia. So this system in Central Europe, it will cause some high impact weather. So stay safe. And that's all from my side. Bruno, you may continue. Thank you.
So, hi everyone. You're now looking a bit on the operational side from the last few days. As you know, in the summer, many countries in Europe have to deal with forest fires, and in Portugal we have had more than 250,000 hectares burned, so almost 3% of Portugal territory, and mainly concentrated in central region during this summer. This fire season was preceded by months wetter than usual, such as January, March, and April, and months drier than usual, like June, July, and also August, contributing to a wetter than usual spring, followed by an extremely dry and hot summer. So now, as a result, in September, so now early autumn, we are still very vulnerable to fire events. 3 days ago, this was the synoptic situation with an high pressure system located northwest from the Iberian Peninsula with its ridge extending to the south, and 2 low pressure systems, one centered northwest for France and another southeast of Spain. And this created a pressure gradient which favored intense northerly winds, mainly over the western coast of Iberia. And this condition started at the end of the 20th and prevailed especially during the 21st of September. Here we have the rural fire danger map forecasted by IPMA to the 21st, and it combines the fire weather index that used wind intensity, relative humidity, temperature, precipitation, and moisture conditions of fuel, and also some structural component which takes into account the type of land, occupation, and the burnt areas of the last 3 years. And we'll be focusing on the southwest of Portugal, marked here by a yellow circle. And you can see that the risk was very high to maximum on that 21st On the right side, we have the Palmer Drought Severity Index based on the concept of water balance and considering precipitation accumulation, air temperature, available water capacity in the soil, and it allows for a detection of periods of drought and their severity. So if we looked at the previous year, we now see that the south of Portugal is less dry this year, mainly because of the wetter spring I spoke about of the 25 year. But despite this, and taking into account the previous conditions, there were no reasons for being relaxed about this part of the country during this time of year. Looking at the observations, and here you can see the scattorometer data from the sensor ASCAT-B on board METOP-B satellite at 2030 UTC of the 21st. The data clearly shows a northerly flow over the sea on the western coast of the Iberian Peninsula, and this kind of flow is very typical of the summer here in this coast, and it extends inland near the coast. And the scattorometer here shows 20 to 25 knots, so around 35 to 45 kilometers per hour of mean wind over water. The image on the left shows the scattorometer wind flags colored according to the Beaufort scale, and some small colored dots that give the value of the maximum likelihood estimator. And this indicates how well an observation fits to the geophysical model. So because here there are no IMLE values, scattorometer data should be of high quality in this case. On the right, we have the wind speed bias plot, so showing the difference between the wind speed measured by the scattorometer and the one forecasted by the European Center model. So it's an observation minus a model value. So therefore, we have red colors that indicate scattorometer wind value is higher than the model, and blue indicates the opposite. And this helps us understand the bias of the wind near the coast, and is also extremely useful, primarily for marine forecast, but this is not the target of this weather briefing. Here we have the data from the weather stations over the southwest of Portugal from the afternoon and early night of the 21st, and Foia weather station, which is located at 900 meters of altitude and near the coast, observed 70 to 80 kilometers per hour of wind gusts, with the mean wind coming from the north direction. And the wind would gradually decrease during the 22nd of September, but will still maintain a moderate intensity. Other stations at lower altitudes predominantly show north to northwest direction with gusts up to 58 kilometers per hour. At 11:21 UTC of the 21st, there was a fire detection on a bush area in Algesur, in the southwest of part of Portugal. You can see here, and the part that we've been looking at. And this fire would have at some point more than 600 firefighters, 200 vehicles, and 10 aeroplanes fighting the fire. Here you can see the MTG Fire Temperature RGB that can be used to detect and monitor wildfires and assess their fire intensity. And this was a perfect day for the satellite to observe the fire because of the large cloud-free area. On the left, we have the 11:10 UTC image without hotspots, and on the right, we have the 11:20 UTC with the hotspot corresponding to the first fire detection. So all the channels used to produce this RGB are sensitive to the temperatures generated by fires in different amounts. So infrared 3.8 channel that you can see on the bottom right corner is sensitive to fires even if they are much smaller than the pixel size of the channel. So small and or cooler fires will only show up in this beam, this red beam, and appear red on fire. Temperature RGB. Moderately intense or large fires are detected in the infrared 3.8 as well, and the infrared 2.2, both in the bottom of the slide. And this combination generates an orange to yellow color in the RGB. And then very intense fires are detected by all the three bands, and so they will appear as white in the MTG Fire Temperature RGB. At 1620 UTC, the fire was already covering a large area and with more intensity. And this RGB provides qualitative information on fire intensity, and the color scheme on the left side helps characterize the intensity of the fire we are observing. In this case, with cooler areas appearing more red, as you can see, and on the borders of this area, and hot areas appearing yellow, so in the center of the area. At this moment, the intensity of the fire was not sufficient to be fully detected in the near infrared 1.6, so there were no white areas here. This fire will generate a smoke plume detected by visible channels, and here you can see the MTG True Color RGB that provides natural colors during daytime and is the most similar to the human eye visualization. Aerosols are better seen here in this RGB because the use of shorter wavelength channels and the scattering effect is stronger at these wavelengths. So here you can observe the smoke plume produced by the Al Jazur fire moving to the south over the sea. We can also see some dust here over Morocco area. Looking at the difference between the HRV from MSG on the left and the true color from the MTG, we can see that it's easier to see the smoke plume on the MTG RGB, and mainly because of the use of the mentioned shorter wavelength channels. So the HRV has a spectral bandwidth between 0.9 to 0.6 micrometers, and a larger than they are larger than the MTG True Color that uses the 0.4 and 0.5. So hence the detection is clearer on the MTG image. On the EUMET view, the online map service from EUMETSAT that you can access through EUMETSAT user portal, we can superimpose the True Color MTG with the Fire Temperature RGB, and using the opacity slider, create a good view to monitor the fire development during the day. Here is showing the fire intensity and the smoke. You can see the fire intensity and the smoke plume at the same time in the same image, which is very cool. And as we were monitoring this fire, it was very useful to see another fire starting near Faro city, between 1640 and 1650, and this is showing in this image. And gladly, this one would not persist, and like the Al Jazur one that lasted very long, is still on resolution at this phase of today. Also, and looking just a little bit to the night microphysics RGB, both of them, MTG and MSG night microphysics, are well adapted to detect fires during the night, and they take advantage of the temperature responsivity principle that says that for the same temperature change, the 3.8 or 3.9, if you were looking at MTG or MSG, has a higher change than the 10.5 or 10.8 respectively. So when fires are present, the green beam has the lowest value because brightness temperature are higher at 3.8 or 3.9, and that brings the green difference to 0, and you can detect them that on during the night with these night microphysics RGBs. Just to end in a different and brief note, and looking more at the consequences of fires, namely the burnt areas from the August fires in central Portugal. On the left, we have the HRV from MSG that take advantages of the visible part of the spectrum from 0.9 to 0.6 to 0.9. And on the right, we have the cloud phase RGB from MTG used here for a secondary aim, and that is to retrieve the burnt areas showing in green color and taking advantage from the big difference in reflectance between burnt areas and healthy vegetation at around 2.25. You can see here, and the small or no difference on the other two channels, resulting in a full green color for the burnt areas, as you can see inside the yellow circles in the central region of Portugal, but also in some other places, namely north of Portugal and some parts of Spain. Thank you very much. Don't miss the next weather briefing in October.